To survive, trees have to lift water from the soil to the leaves that can be many meters above the ground. They seem to do it effortlessly for a very long time and without failing. So how can they do it? How can they lift all that water up there? They don't have a water pump. They use evaporation. Evaporation is a major force of nature that our society seems to have neglected for a very long time. We use the power of falling water, we use the power of wind, and we use them to transform agriculture, power generation, transportation. So think about how this major force of nature, evaporation, what it can do for us if we can harness it efficiently. We came across with this question through a serendipity. My lab develops special microscopes to look at small things and probe their mechanical properties. At one point, we were studying bacterial spores. Spores are dormant organisms. They do not need food to survive. We found that spores are extremely rigid. And this is very surprising and interesting because spores change shape in response to changing humidity. When it gets humid, spores take up water, they get bigger. When it's dry, water evaporates and they get smaller. For a rigid material to change shape like this, it must take a lot of energy. Actually, we calculated it. We found that half a kilogram of spores have enough energy in them that could lift a car a meter above the ground. That's a lot of energy, and you would think that has to have a lot of applications. Well, spores are so tiny, so how can we create larger structures from spores to make something useful? It turns out that spores mixed with glue can be pasted onto surfaces, and they would make the surface move. Spores will push and pull each other, and they will bend the underlying material, transfer energy to it. It can respond to changes in humidity quite rapidly. And this is very interesting, but in nature, you don't have rapidly changing humidity. Instead, we have evaporation from large areas of open water. If you make a horizontal device with shutters, spore-based material can expand and contract as the water evaporates, moving back and forth, and it means there's power. You can then use this power to do something you want. Well, to do this, we have to have a material that can expand and contract horizontally. And we set out to do this. It turns out that designing the material by pasting spores with a special pattern, you can achieve this. You can create wavy shapes of plastic that can quadruple their length as you bring them from dry to humid. You can stack many of these materials, and then you can lift weight as it gets dry, and then you can lower it as it gets humid. Now, if you have a material like this, you can place it on the surface of water horizontally, and you can then use some shutters to control evaporation. This material is actually working very much like a muscle. It's controlled by humidity, and when you then put all these things together, the shutters and everything, you create an evaporation engine. It sits on the surface of water. As moisture from the evaporating water fills the box containing this muscle, muscles elongate. They open the shutters, and then moisture escapes from the box, gets drier, muscle gets shorter, shutters close, and then the cycle keeps on going. You can connect this engine to a generator and produce electricity with it. You can do whatever you want. You can generate light. All you need is a standing body of water and a simple device. You just put this device on the surface of water. Well, to make this demonstration, we actually cut so many corners. It can be much more powerful than this. We calculated it. We used weather data across the country, and we calculated how much power you can generate. We found that evaporation can give you as much power as today's solar and wind power technologies. But equally interesting, we found that harvesting energy from evaporation would lead to savings of water because you would slow it down. There are two major societal needs. There's something even more interesting. The body of water that evaporates is actually a natural energy storage device. If you don't use the energy, it stays in the water as heat, and you can deliver it whenever you want. So we calculated again that throughout the year, you can match the power demand and power supply without needing external energy storage devices. So in the end, evaporation has many potentially transformative properties. It works with biological materials. It works mechanically. It can store energy in it, and using that, it can deliver power on demand. And as you harvest energy, you would also save water. The potential applications could be limitless. And as you see in this demonstration, we have an evaporation-driven car. There's water in the white-colored wet paper. That water evaporates through the device, and it makes the circular engine rotate. And the engine is connected to the wheels, so it pushes the car forward. You can think of giant versions of this producing power. So the applications are limitless, and we don't know where to begin.